Right. So I've got the future of Cassandra project and what it means for cloud native. Of course, I introduced Patrick earlier, but he's the principal technical strategist and Cassandra committer at DataStax. Um, I want to give a special thank you to our DoK community sponsors, of course, our platinum community sponsor, EDB. Without EDB and our other sponsors, we wouldn't be able to put these talks on and do things like DoK Day. So really appreciate their sponsorship. Uh, Speaking of DoK Day, so that's coming up pretty soon in November 10th in Atlanta, Georgia. So you can register now. It's probably better if you're going to go to register. The earlier the better because the ticket prices always are going up. What's great this time, it's going to be hosted. Oh, I left an E off his name, so typo, but it's going to be hosted by one of the DoK ambassadors, Divine Odazi. So a lot of you probably know Divine. He's done some talks and he's pretty active in the community. So yeah, I'll be excited to have Divine lead DoK Day. So hopefully y'all can attend. And then we have the DoK report. So we have the questions written. So we'll be putting out a survey pretty soon. We're just kind of finalizing the questions. Once we get the data from that, we will then put out a report. And the goal is to have that report out before DoK Day. So look forward to seeing that as well. And then upcoming in October, we have a talk harnessing event-driven and multi-agent architectures for complex workflows and generative AI systems. So that's with Mary Grigleski, Regional Director of the AI Collective. So that's in 1 month on, as always, the third Thursday of the month. In this case, it'll be October 16th. So yeah, looking forward to that. And if you want to register for that, you can go to the DoK meetup.com and look for DoK. I probably should have put a link there, but I think if you're here, you probably know where that is. So go check that out. Lastly, if you just want to be more involved in the community, you can scan the QR code on the left. That'll take you to our community page on our website. And then if you're interested in sponsorship, you can scan the QR code on the right, and that'll take you to our sponsorship page. And you can always reach out to me or Melissa Logan, the director of DoK, if you have questions. Yeah, otherwise you can look at those pages and get information. Well, that's enough yapping for me. I'm going to pass things over to Patrick.
So good yapping. It's important. It's important.
Yeah.
I'm a strong supporter of DOK. Being here since early days. I think it's amazing, amazing community for an amazing thing that we're doing. So
Awesome. Oh, I should mention real quick, if you have questions, put them in the chat. I'll pass them along to Patrick, and Patrick, feel free to answer them when you feel it's appropriate,
on the
whether that's at
fly,
the end or during the talk. So,
I should bring up the chat window. Hold on, let me do that real quick. There we go. Okay, now I have a chat window up. I can see your chats.
awesome.
But I need to see, like, somebody needs to say something. What? Is there anybody even here?
Yeah, let us know. There's
Yeah.
at least a couple, so let us know where you're
Yeah, like
watching from.
the two people that are in here, but I know this is being recorded too, so that's the thing.
Yeah.
Um, okay. Well, hello everyone. My name is Patrick McFadden. I have many hats. I, as Paul mentioned, I've been at DataStax for a very long time. Now I'm at IBM because IBM decided that DataStax needed to be a part of the family. So I'm about 30 days into that. So I'm a principal technical strategist at IBM now, which is a cool title. But more in my roots, more in my core being is being in the Apache Cassandra PMC. I've been doing that for quite a while, and you'll know me from that if you know anything about Cassandra. But I also had a lot to do with where the movement is going with running any data workloads and Kubernetes. And Kubernetes has been on my radar ever since I was using Mesos. And but years ago, I wrote a book with Jeff Carpenter, managing cloud native data in Kubernetes. And surprisingly enough, it is now really starting to ramp up on sales. And I think it's just because we got there a little early. It's good, but it's becoming a now problem where more and more companies are like, how do I deploy this in And we're moving all our infrastructure into Kubernetes, and the data needs to go with it. So in EKS or AKS or an OpenShift, or what have you, some managed Kubernetes service. However, we're managing everything in Kubernetes because, as you remember from my book, because everyone read it, I'm sure, we're not building virtual machines, we're building virtual data centers. And those virtual data centers are being deployed with the full stack. And the full stack includes data. I don't have to tell you because you're here at DoK. And that was an interesting long bit of research that I did with that. And since then, I've gone through this process of, just thinking like what's next. And what's part of the book was like adding this section in there about like the future, like what does it look like, AI ops, that sort of thing. And that was back when AI ops wasn't even a thing. And but there's plenty of people I talked to, and that was part of the book. A very important part of it is interviewing smart people that are on the cutting edge of things and seeing where they are. That's a feature of the book because there's an interview in every single chapter. There's two interviews per chapter. Um, and the directionality is like more automation, more cloud native, more emerging infrastructure. So that's kind of cool. But the database part of it, which I've been involved in for a very long time, it looked like there was a directionality to that. And I say this research creates research. And now I'm on this thing of this post database era. And those of you who work on databases are probably going to shriek in horror. By the way, full disclosure, I'm going to just put this out there, make sure everyone knows. This is not official word from either IBM DataStax or the Apache Cassandra PMC. This is me, the individual. I'm sharing a lot of my own research, sharing my own points of view and directionality, as a matter of just being open about like, hey, I've done 6 months of research so far on this topic, and I've learned a few things, and I want to share them with you because I think as a community, we work together better. Then there's no competitive advantage of knowing this information. The competitive advantage is being able to do something with that information. And it's going to happen anyway. But the post database era is something that came up in my mind. And it's not that we have that database, people who work or build databases are going to be completely unemployed. On the contrary, you're going to be employed for life. I'm sorry, you're stuck. But it is going to be much different from the top down. And this is the thesis that I'm working on is that in this next decade, I can see where the database brand between developers and the database brand will break. And right now, developers tend to, maybe not always, and if you haven't seen it, then you're just proving my point. And because of this movement is happening, the developers tend to say, oh, I'm writing a LAMP stack, so I need MySQL. I'm writing something quick, I need Postgres, oh, we're building this massive thing, I need Cassandra. They're very specific about what database they use and why, because databases have this thing where they're like, no, this is a very specific use case that we do, or it fits into a certain thing. It fits into a box. And so part of that is that databases will be consumed as storage with an API. Developers simply choose the API they need, not the database product behind it. That's the thesis that I'm working from now. And and any thesis needs to be disprovable or provable. And that's just been the research I've been doing. It's like, okay, what are all the things that prove or disprove it? And that's what I'm going to talk about. And then like, what do we do with that information? So this is all true. The need for data is not going to stop. It's only going up. And AI is a great use case of like why we need more of it. But apps get built. More companies are becoming digital native. This is not stopping. No one has ever said we're going to have less data. Just isn't going to happen. And then but on the flip side, data is money. It's cost. It's a cost center. If you work in infrastructure, your overhead. And so the requirement that I've heard from so many companies is we need to reduce our complexity because we have overly complex systems. And the reason is we need to save more money. Complex infrastructure is expensive. And it's not just expensive as in running it, it's expensive as in trying to run it, from getting the right people. You may have to have groups of specialized people. You may have ways to mitigate downtime because of the complexity is so crazy. Simplifying checks a lot of boxes when it comes to lowering costs, and that's just the name of the game. I think we've all been in those conversations where we need to reduce our infrastructure spend by 10%, 20%, half, whatever. And these are the three things that you spend money on in cloud native: compute, network, and storage. Everything else is derivative. And it's, of course, makes sense because, let's say, for instance, you use a cloud like Amazon or Google, or I hear people using Oracle now. Um, they're selling you three things because this is what their cost was. When you build a data center, you wire it up for networking, you slap in some racks with a bunch of compute, and they're connected to storage for long-term storage. That's it. And those are the things that cost money because they consume electricity and need cooling and people to run them. Services and everything else that are on top of it are just ways to get you to use more compute, network, and storage. If being a VAR, I've worked with a lot of clouds, and it's hilarious how um, I've worked, and this is just a proving point. I work on Apache Cassandra, which is an open source project, and I've worked with Amazon sellers to sell more Cassandra in some groups because they know it consumes a lot of compute, network, and storage, and that's really what they want. And yeah, you can use Dynamo, you can use Aurora. There, there's plenty of choices, but all of the choices combined fit this bill. So the trends that are happening right now in database and storage are what I want to talk about initially. And then this is the uh, this is the fun fact of before, and it was an interesting thing I hadn't even thought about, but here it is. The database proliferation was really big in the 2010s. It kicked up like 2008 was when things really started to start and go, and lasted for about 10 years. And this is how many new NoSQL and NewSQL databases were introduced in that time frame, but also the number of cloud-only databases that were introduced in that time frame. And if you think about why, I was there, 2006, 2007, struggling to get MySQL, Oracle, Postgres to scale to this ridiculous thing that we were creating on the internet. And so we were looking for alternatives. And just like good engineers, we invented new ones, a lot of them. Not invented here was definitely in play. And there are a lot of different things that just never, I mean, there's some things that never lasted. There's some things that did. Mongo, Cassandra, Redis, those are examples of the NoSQL thing that happened. Like they were born of like in that 2008 to 2010 range and have since survived the culling. And on the cloud side, it was some implementations of, but also new things like DynamoDB, for instance, or Firestore, that were meant to be cloud only, but it's this proliferation of choices, and so developers are like like losing their mind because you can pick like 10 different databases. And that was what the problem now is, because of that proliferation. um, Organizations have a ton of database choices and they have to support all of them. I've worked with orgs that have 20 different database products. 20. I didn't even think that was possible. Some more, a lot less. I mean, 10 is a good number, but rarely. The only time I've ever seen one database in use in one organization is if it's a startup and it's their first week. So the shift is happening now. We are moving to back to this consolidation that's being driven by those things that I mentioned before, which is, hey, we have too much complexity. Hey, we're spending too much money. Duh, you have so many databases, and and every one of them is for one specific use case. There's that conversations happening everywhere, and this is an interesting discussion, or a survey that was done by Redgate, which is a data management platform. They surveyed their users, and it was very interesting to see how things are changing, like from the 2023 to 2024, how there's a huge shift, like more than five um dropped. More you have orgs that have more than five databases dropped by 20% in just that one year. So it's happening fast, and the consolidation is a contraction of the database market into fit for purpose, like instead of just having one database per use case, we're going to have one database for multiple use cases and fit for purpose. And if you didn't think this could ever happen, I'm going to call out something that did happen. This happens all the time. And this is one of my favorite examples because I was involved in some of this stuff, and that's file systems. If you were involved in Linux file systems in 2000, you knew it was quite drama. People made their stand on things like Riser or XFS, and for good reason, right? They they fit better than ext3 or what have you, and that has slowly just disappeared into the background. Where and think about developers. Developers used to ask for specific file systems, and I was there because I was running infrastructure, and they're like, "Well, make sure when you install that it has XFS." Okay. Um, Now no one cares. They just deploy an image, and people who do care are the people who care. Like if you work in storage, then this is an important thing for you. But you're going to provide whoever with an image, with a Docker image or something baked that has a specific file system in it. And developers never ever asked for it. It has turned into the invisible part of the infrastructure as it should. We do not need that more complexity. Databases are going that direction. Yes, you will be using Cassandra. Yes, you will be using Postgres. Uh, you just won't be asking for it by name. And the thing that's driving really, really hard in storage right now is this object storage economics. It's just so unbelievable how fast this has grown. A trillion objects to 400 trillion objects in 10 years, 12 years. And it's being used for all sorts of stuff. Now, I got this data from Amazon because they're really good about publishing stats, and I appreciate that for my research. But I think it's a good thing to look at cross purpose. You can generalize this quite a bit. So the transactional analytics, AI and ML backups, all those things now are being done in Amazon S3. If you look at Amazon's latest, they had some stuff where they're doing vector search now on S3 buckets. And um, of course, they've been enabling a lot of AI and ML workloads, like using Presto on top of S3. And they're just making it, yeah, this is our deal. This is our file system now. And um, the amount of growth in that is picking up and almost passing block storage, which is crazy. Um, and this is the reason, because I'll start with the second bullet. That SLA is durability SLA is crazy. 11 nines. That is, you're going to retire without it losing a bit. That's great. And that that's really attractive. But the best thing is it's only 2.3 cents per gigabyte. And it's been like that. And this is what's an interesting fact is that they set this there was some pricing wars on object storage back in the day. They have not changed the price in like 10 years. It's always been 2.3 cents a gig. So it's very reliable, but it's also not being adjusted for inflation or anything. It's just fixed. And so when you think about like predicting costs using object storage is not only predicting costs, but predicting that your data will still be there after a while. And object storage has fit that bill really nicely. You're going to get a lot more variability in block storage, and there are still use cases that do not work outside of block storage, either local or attached. But AWS has been like, just here it is, mic drop. This is our cheap durable storage, and the industry in general has responded. I can tell you that this is something that DataStax, our cloud service that runs Cassandra, mostly based on object now, because that's how we can get the most reliable price, and we can charge someone like X amount to run a Cassandra cluster. One of the reasons we can do that is because we use object storage for all the long-term storage of the data. And then developer expectations is changing a lot. It used to be that I need an API. I use an API and then I find the purpose. But now it's like I have a purpose and I'll just use an API for it. And I'm not saying a database product, I'm saying an API. And those APIs are, which I'll get into in a minute, are are coalescing into common data access APIs. I'm not saying it's all REST or GraphQL or anything. No, no, no. I'll get into that. But query syntaxes, the amount of databases that are supporting more than one has been picking up quite a bit. And it's because you know that the use case generally follows some sort of access query patterns, a query pattern that needs to be mimicked. And if you want to have more access to more use cases, then you explore the amount of query syntax that you can offer from your data store. Again, I could say that from example, our cloud service takes multiple query syntaxes to get data out of Cassandra to the point now where a lot of developers have no idea they're even using Cassandra anymore. They just don't know. They're using Document API. Okay, great, and it's Mongo compatible. They just move on with life. They don't even think about like what's running underneath. That's kind of the whole their dream for database providers is that they just they become an appliance, and it's getting there, but where we're at right now is not a lot are doing it. And if you think your particular syntax is just going to disappear, let me show you COBOL. COBOL's still around and it's still there. So if you have a very I'll just use Cassandra as an example. Cassandra has CQL. CQL is Cassandra query language. Um, there's somebody that's going to need it 10 years from now pretty easily. There's someone who's going to need it 30 years from now. And so it's not going to go away. And Cobalt's a perfect example. It just keeps on trucking. And I've talked to so many developers who said, man, back in the day, I still use Cobalt here and there because it shows up. Yeah, it does. And the API consolidation this is a good example of like what the consolidation looks like. And Postgres, a PG SQL specifically, has turned into like a lingua franca of SQL, and there are plenty to choose from. And you would think ANSI SQL would be it, but ANSI SQL is a little flexible, a little amorphous. And yeah, and if you ever look at the ANSI SQL standard, there's a lot to pick from. But to make it really just kind of like, oh, this is compatible with Postgres, that's the thing. And you look at how many different services and products out there are just PG-SQL compatible. There's a lot, and they're picking up, and it's just because the complexity for developers is needs to be reduced. It doesn't matter what you're running behind it, as long as you can get to it with the same SQL syntax dialect, then you're reducing the amount of friction for developers. They just need to know, like, oh, this syntax is appropriate for a select query. Great. I don't have to think about like, oh, how do I do an aggregate of that? No, just type it, and it's the exact same thing. Funnily enough, this is actually really good for when you use AI to build SQL. And because if you have a really common set of SQL dialects, one dialect to rule them all, it makes AI really easy to come up with the right query syntax. And I know that because whenever I write CQL and I have the AI try to figure out what's up, it always injects a little bit of SQL stuff in there that's wrong. And because the training set is like, well, I know most of that, but you just went sideways on me. What are you doing? And it's just this complexity is a lot of money, and complexity is failure. We're just reducing the amount of complexity in our systems, reducing the surface area of errors. And so I made this call. I'm making this call of like, what are the API winners for data access? And um, for SQL, it's Postgres, the PG SQL. That's the clearest winner I can see, and that's the easiest one to call because there's just so many things that support it. Um, and it's not that crazy of a dialect. It has a few things that are a little different, but it's compatible with Oracle, which is interesting. A little different from Mongo, which is also super popular, but it wouldn't take much of a change to get Mongo's SQL very close to Postgres. And for key value, Redis and Valkey have nailed down this like RESP. That the API that they use and how they work with key value is granted not very complicated, but that's the one that seems we've settled on. And there's lots of services that do that. For document MongoDB, their document model is in the sweet spot of standardization, and that's been a bit of a that's speaking of drama. Like I don't know if you saw this document DB, if LF adopted document DB, which is a document API on top of Postgres, and Mongo had sued, was it FerretDB? I think it was Ferret, yeah, because they were talking about Mongo compatibility. Well, man, it's out there now, and Mongo compatibility is this easy thing. And why? It's not because you want to like say, "Oh, we give up." No, you just want to make it easier for developers, and they're still using your database. They're just using a different API. For search, we've seen hands down winner, but that's Elasticsearch and OpenSearch. That query syntax for search, nailed it. And for graph, right now, Gremlin and OpenCipher are the two things that are prevalent. However, everyone's moving towards GQL, so I'm going to call that as the winner because everyone's just like, "Oh yeah, that's what we're doing and that's where we're going." Um, and the GQL, if you don't know about it, is, and then there's also this SQL variant on top. We'll see, but I'm calling GQL as a winner there just because it is what everyone has agreed that they want to do. So here's the future. The future is happening, and what it is this massive, like this incredible field of individual little tiny things like the snowflakes and the neos and the redis's, and everyone has got their own specialty. Everyone's got their own thing. It's heading towards a singularity. And that singularity is really developer driven. It's not people who build databases. People who build databases would love to keep their island, but you're not. And the key is just evolving or fossilizing. And this is what I told our. I'm going to go into some stuff about um, what I told the Cassandra community, or this Cassandra community this weekend, of about how we are going to continue to evolve in the next 10 years. So this is specific about Cassandra, but I want you to listen to this in general about like what this means for every database. Because this is what I'm putting forward as a PMC member. I'm saying I think we need to consider this. I think this is our direction. And it's being debated right now. And this is the takeaway is this is the general direction for all databases in the world right now. This is where we're going. So I just wanted to give that preview because uh, I'm doing this as a Cassandra PMC member. So you're going to see lots of Cassandra stuff in there. All right, let's see. Next. Okay, so there's these steps that I have for Cassandra that this is what I want to do, and we will debate these publicly and we'll see where it goes. But first one is just we'll deprecate CQL, Cassandra Query Language. It's done its job, it's done a great job, and it's gotten us to where it is, but I want to move us to PG-SQL or PostgreSQL standard. And we're pretty close actually. It's a funny thing when you look at the grammar for SQL, it's mostly SQL. And but we need to just stop being special. And because the thing about Cassandra that's special is the way that it works. Um, it's not the language. The joke I always have is nobody's going, "Wow, I really need to use CQL. I wonder where I could run it." No, people don't ask that. They're like, "I need a database that is globally scalable, that is massively consistent across multiple data centers, that is highly resilient in open source and blah blah blah." And then they're like, "Oh, well, there's the one database. There's only one database that does that, and there it is." And then, "Oh, I have to use CQL. All right, I guess I'll learn it." No one's excited at that point. If we stop that and we just make it easy, then it'll be no problem. And then we'll get there. And so the idea is that Cassandra then just becomes a general purpose database for multiple use cases. In this particular case, but people will deploy it for the thing that it actually does really well, which is a highly scalable distributed database. And adopting object storage as a first class. We've already gone down this path a bit here and there. This is just committing to the directionality, and we have some ways of doing tiering into object. Mentioned the DataStax is deploying Astra pretty much all on object storage, and for good reasons. But this is going to be a concerted effort by the project, and that just it goes directly to the storage engine and how we operate with that. Object storage has got a completely different set of problems that we need to think about, especially when it comes to durability from the database side, like syncing to object storage. A lot of these problems are being solved right now by other databases, and so we're we're doing some solving. They're doing some solving. There's lots of solving going on here, but it's just engineering at this point, and getting into life cycle policies and the tiering and some of the ways that object storage has more ways to save money. There's a lot you can. 2.3 cents per gig is the basic price. You can get even less if you get into some really interesting tiering strategies. Um, so we have and then commit log is the hardest one because that's your write ahead log, and that's the durability in Cassandra. How are we going to work with that? But it's the outcome that we're trying to drive is that the cheapest storage, the cheapest thing you can run is the first class, and just that's it. We're not saying you need to use super expensive storage. And there was an era where we did. We said the most expensive part of your infrastructure will be Cassandra because you have to use the good stuff. We're going to flip that. And then there's this idea we have and if you're not haven't been paying attention to the Cassandra project, we have different sub projects which are very very much moving fast, high momentum. One of those is the analytics sub project at Cassandra, and that's being able to run analytics off of live Cassandra data or snapshot Cassandra data. Very typical situation is we have people doing petabytes, millions of writes per second, and so they don't want to move. So you could get. I think one of the use cases that is pretty interesting that fits right into this is there's one group that's doing about 3 petabytes a day of writes into Cassandra. Doing ETL on 3 petabytes is just not possible. I mean, you're not gonna. It's not practical, I should say. And so it's how do you use the current data files to do things like analytic rollups? Because Cassandra is not really built for analytics. It's built for transactional fast data. That's your OLTP. But OLAP, which is also a pretty well solved problem in many scale environments, is around Parquet and Iceberg and things like that. So we've already gone down this path a bit with HTAP. What I want to do is commit fully into it. So that's just part of the overall storage mechanism and a part of the query structure. So if you write a query, then it can pick a path, either fast or slow path, and we have everything inside of it ready to go. So you don't have any ETL anymore. Again, this is developer focus. Developers don't have to think about it. They don't have to make a request. Oh, I need to have some OLAP on top of my OLTP. They just make the query, and yes, guardrails, things like that will occur where we don't maybe want you to do that, but that's more of a runtime problem. We're going to let operators figure that out. But the database should not say no. And then the big one is the unified gateway business. This is something we've already experimented in a couple of projects. The Netflix has their data gateway, which is a very interesting non-open source project. They're getting ready to open source it, which is very fascinating. It's a different. It's not. They're not doing all this, but this is what I think is going to be the path forward. Is just having the coordinators. The coordinators are the individual nodes on Cassandra, being able to support multiple dialects: SQL, document, KV, search, graph, and SQL because it'll last forever. The coordinators should not care about like how you ask for your data. They should then pass that request blindly down to the storage engine to be serviced in the way that it's being asked for. And so this there's some details about implementation in here. I've already kind of started working on some of this, which is working on this parser boundary with the query parser service and thinking about in terms of like how do we manage multiple dialect query. And some are easy, like KV, SQL. Some are hard, like search and document. And graph is just a completely different thing. It's mostly analytics. So this is a 10-year outlook though. So just keep in mind this is a 10-year outlook and this is a directionality. And then the outcome that we're trying to enable is people just say, hey, I need an API and it's on I need an API, and they should always use the same endpoint. They should have no choice of like no worry about having multiple pieces of infrastructure to coordinate. Here's an endpoint, it does all these different things. One host name, one op service. So the 10-year roadmap that I'm proposing for Cassandra, or I have proposed for Cassandra, is like looking at how we start shifting in this direction to being just, I hate to use this word, the whatever database. Hey, what are you bringing? Whatever. All right, cool. And these phases are like stuff that's happening in the next, we can easily do in the next few years are the ones that we're already working on, like SQL compatibility mode. We're already working on it. Tiered storage, working on that. Parquet projections, there are multiple groups working on multiple implementations of this, but it is a thing. And so when we get to a place where we have a formal proposal, in the Cassandra project, we have these things called CEPs, which is the Cassandra enhancement process. And that's when we start getting serious about changes and implementations. Because it's a large open source project and it's we have a directionality we have to manage. It starts with a discussion on the dev list or discussion like this Apache conference. There's like 50 of us in a room, and then we have hallway track because hallway track's the best one, and then it turns into a dev list discussion, and then eventually it gets formalized into a CEP. CEP has the full rundown of this is what we want it to be. The CEP gets adjusted, changed, modified, all the things that need to happen, and then it's finally voted on. And once it's voted on, that's the new law of the land and or directionality. Some CEPs just never get off the finishing and get to the finishing point, and there's maybe two or three that are in our stack that we're kind of wondering like, well, are we going to still do this? But mostly they're fast movers. We've had some really cool ones lately about like doing like how we manage SSL certificates and constraints across multiple security boundaries and certain things like that. They're a little more operational. They're more in the weeds, but they're always driven by someone's need. Every CEP we get is driven by need. This will be more aspirational CEPs, like, hey, we want to be something different, and that's a group think. So I'm just kind of went into the process of how we change things in Cassandra, but um, this is the I don't want to say easy. It's the easy one to call out because it's stuff that's actually being worked on now. The phase two stuff is like in the next 5 years. What do we really want it to look like? And these are also just derivative of things that are happening now, but with a logical conclusion in the next 5 years. Having a unified gateway, um, having primary object storage, not just a option of, oh, if you need object storage, it's over there if you look sideways. And then now it's just this is the default's on the box. And then having a really qualified analytics path. We have our cost-based router that's being developed or talked about right now, how we land with Parquet and iceberg projections, that sort of thing. There's a lot of great projects in the Apache Software Foundation, like Dataflow and Gluten, Apache Gluten, that we can start introducing in. I mean, there's so many interesting open source projects out there. If you look around, you don't have to do this alone. Just join up in a project and add your 2 cents. And then the final, a little more fuzzy, but I called it the next 10 years. Like, where do we want to be? We want to be completely language agnostic, dialects, all the dialects. So whatever language you want to bring. And there'll be plenty of debate. Like, will those 5 or 6, or maybe we'll have 4 languages? Who knows? I mean, maybe Graph will get folded into SQL and that'll be that. Who knows? But as it sits right now, this is in 10 years isn't that far. That was a Bill Gates quote. I think what was it? People always underestimate or overestimate how much they can do in a year, but underestimate how much they can do in 10 or 5. It's just a lot of unknowns, but we have a direction, and I think we should get there. The full HTAP, we should just be a database that can do anything you need it to do. Because really, it's managing the consistency and distribution of data. And distributed databases are super hard, and we solved that problem a long time ago. We have a very good system in that way. Now we're just adding useful things to it, and then uh, this is something that we've been talking about for a long time, but I think this is where we'll see this. There'll be things there that need to be there first, like being able to deal with the API that will be able to read any data format. Because of the way Cassandra storage works, it doesn't get too picky about what's underneath, or it doesn't have to be picky about the data that's storage. So like you can just drop your Postgres files in there and it'll take them. Thank you. And that would just be great for a lot of operators if they're trying to move data around, and you don't have to actually move data like using a migration tool. You just move the files. That's a big one. I don't know if that'll happen. I'll see you in 10 years. And the way that I think any of us will get there with our databases as we're evolving into this new era of what a database actually is, and this really this post-database era, is data is still important. We're still going to use a lot of it. And how we use and store data is super critical. So we have to be pragmatic about things. And this is always my best advice for anyone who's working on changing a database. Databases are hard to change because people get locked into it. And you don't want an upgrade to ruin things. This is something that we take very seriously in the Cassandra project. If you're on Cassandra 4 and you want to go to Cassandra 5, we have such an intense amount of testing that's done because we do it online. It's not a migration. You just upgrade in place and you can't have any downtime. And it's worked out pretty well. We have some clusters as of the last, what was it? Last year we had a survey and there were some clusters that were up 10 years without a downtime. Crazy. 10 years. Like, when did you start? But it happens. But to do that, we have to think about like how we test and how we roll things out. We have to think hard about setting defaults and also making things opt in. If you work on a database, if you were deploy a database, those two things right there are really critical. Like, I don't want your default that will destroy my system. And I definitely don't want to be forced into a new thing until I'm ready. I should have the ability to opt in when ready, or I've tested it myself, or whatever. That's also really critical part of this new era of databases because they can't go down. They can't cause problems, or else people are just going to run the old database forever. And that's true. I mean, in Cassandra project, we have people using Cassandra 3, like a lot. And Cassandra 3 was released like 10 years ago. And they're just like, yeah, it works. We forgot about it. We don't want to upgrade it. It just works. Leave it alone. It's been running for 10 years. Leave it alone. Um, so yeah, that's the thing. But to get there, we have to be pragmatic. And this was just more of like, I want to talk about like how we always get there, as we say, discuss, document, plan. And for open source projects, and this is more guidance for any open source project, is we have to think about how you show up. So when you participate in an open source project, that's changing the future. How do you show up? Who are you? In this case, are you an operations person? Are you interested in the core database? Or however you show up? But also the discussion and the documentation of the plan is really critical. This is how we plan nicely in the future and be nice to each other. Be nice to each other. Nothing is personal. That's all I had. And I will take any questions. I don't see any in here, but I am always available on lots of platforms if you have disagreement or a discussion you want to have with me on this.
Hey, yeah, no, that was awesome, Patrick. I really appreciate it. Yeah, there's no questions so far in the chat, but I guess I just have a question in terms of like the 10-year roadmap. I mean, how do you see like cloud native affecting that timeline? Like, what do you think needs to happen
Cloud
on
native
that
is
side?
driving. That's the thing. Cloud native is the driver because cloud native equals complexity reduction, cost savings. Yeah, how do we do more with less? So everyone who deploys Cassandra is either is having the discussion or has had the discussion around cloud native,
Sure.
and maybe there's a few that haven't just because they forgot about the Cassandra cluster 10 years ago. Um, but it's material. this is why the Cassandra project exists, is because there is a real push to get that, you know, get a cloud native version of Cassandra rolling. DataStax Astra runs completely in Kubernetes, 100% of it. We have 30,000 clusters that are running in Kubernetes.
Wow. Um, yeah. And then, so if somebody, I know it can be like a little intimidating for people who are interested in getting involved, like in contributing to projects. Like, what would be your recommendation for getting started?
Yeah, if you're interested in an open source project, we had a panel about this weekend at the Apache conference, and it this is the number one problem. Every project is looking for people to get interested and involved because no, we don't have we're not overflowing with volunteers. No one is. And so, first of all, you will be greeted very warmly, uh, but just show up with what you want to do. And that's okay. If you're like, hey, um, I found a bug, great. Reporting a bug is contributing. That's a contribution. If you're using something, I tell you, so many open source projects out there, and I'll bet you all the maintainers that are listening to this are shaking their heads. Would love for end users to talk more about how they use the project or the product, because that sharing is really that's one of the most critical contributions out there in open source. Is just hey, this is how we use it. This is how we deploy it. This is our use case. And people love that stuff. And it could be anything.
Yeah, that
But
makes a lot of sense.
if you're really if you want to become uh like a core contributor or a committer, and that's Apache sense, um, just ask, how do I do this? What's your path to get there? And there'll be plenty of people to answer that question.
Yeah, yeah, awesome. Yeah, I would say in some people I know, one of our ambassadors for DoK, I know getting involved in CNCF. One of the things I think the way they started contributing to projects was just like translating documentation, and it was just into Spanish. It was just like an easy way I think to get involved. But I think it's just sort of a I think it is sort of like a baby steps approach because it can be a little intimidating. So doing the things that you can do, I think, are the easy ways, handling low hanging fruit, right, so to speak, get you just sort
Yeah,
of
and
comfortable.
ask because everybody has that. Everyone, we all know that it's intimidating. Like Cassandra Project's massive. It's like, walking into a new country. There's like cities and people everywhere, and you're like, how do I even make a contribution here? But every open source project, anyone who needs contributions will usually have like how to contribute very front and center. Like this is how you do it. Yeah.
Yeah. All right. Cool. Well, yeah, you're fresh off of community over code, so and so I appreciate you also coming to taking the time to speak with us. Now hopefully you can take a little bit of a break, or maybe you're just as
Oh, not
busy
a
as ever.
chance. Not a chance. No,
Yeah.
I'll be at Tech Exchange in a few weeks. That's the big IBM community conference in Orlando. So if you're there, come say hi. I'll be talking
Where?
about Cassandra.
Yeah. Where? So where are the best places to reach out? I know you said there's a bunch of ways, but like where like LinkedIn or
For me,
yeah.
LinkedIn is always best. I do a lot of interaction there. I'm also on the ASF Slack. If you do not have an ASF Slack login, um, you can ask me. You can just pop on LinkedIn, say, "Hey, here's I need your email address," and then I can just send you an invite. The ASF thing is funny about how the Slack thing works because I guess they used to have a way that you could just join, and they had so many bots that now you have to go and ask somebody. All right, but you can ask anyone who's already in there. It doesn't have to be anybody special. They just need to have someone who can paste your email into the box.
Oh
Yeah.
yeah, I think you can ask me too. I think I have the ability
Oh
to do
yeah. Well, you're in there.
that.
Yeah. Come
Yeah,
on.
I'm on there
Yeah.
too. So if you
Yeah.
add
Yeah.
me
Yeah.
to the Slack, there's a lot of conversations going on there. So you can ask me or Patrick. All right, cool. Well, Patrick, yeah, thanks again. Appreciate you taking the time to do this again. And yeah,
Yeah.
hopefully hope you spark some interest in Apache Cassandra. And yeah, we'll catch up with you down the line.
Thanks, Paul.
All right, thanks.